this Times Techies Talks. I am John and I will be moderating this discussion on the role of purpose-built high-bandwidth connectivity in data centers in this age of AI. We are doing this in association with Astera Labs, which is building a new kind of connectivity infrastructure. On Times Techies, we have been discussing how AI is making necessary very different kinds of IT infrastructure. A variety of companies are today developing chips that are suited to the high compute parallel processing demands of AI. Similar requirements are emerging on the connectivity side because AI servers have multiple different kinds of processors on them. And that is what we will discuss today. For this discussion, we have three highly accomplished professionals in the semiconductor space. We have Sanjay Gajendra. Sanjay is co-founder, president and COO at Astera Labs. Sanjay grew up in Kudramukh, did engineering at Malnad College of Engineering in Hassan, and joined Wipro on graduation in 1996. Sanjay worked at Wipro for over 3 years, during which he moved to the US. He then worked at National Semiconductor and Texas Instruments. In 2017, together with two colleagues in Texas Instruments, Jitendra Mohan and Casey Morrison, Sanjay founded Astera Labs. Welcome, Sanjay.
Great. Thank you, Sajid. Great to be here.
We have Jitendra Chaddah, JC as he is called, is VP and country head for India at GlobalFoundries, the company that manufactures integrated circuits for a variety of different purposes. JC began his career at Intel in 1996 and was at Intel till as recently as 2022. He took on multiple roles across countries, including the US, Mexico, and India. He served as the chief of staff to the VP and CIO of Intel Corp. His last role was as country manager for the global supply chain at Intel India. Welcome, JC.
Thank you. Pleasure to be here.
And we have Shivananda Koteshwar, sorry, Shivu as we all call him, is managing director and India site head of Astera Labs and is responsible for the design and development of all ASIC products and operations functions. Prior to joining Astera Labs, Shivu worked in various engineering leadership roles at Synopsys, MediaTek, and Intel. He has nearly 30 years of experience in the semiconductor industry. He's also very active in mentoring startups. Welcome, Shivu.
Thank you.
Sanjay, let me start by asking you, when we hear all these big changes now happening in the semiconductor space, in the AI infrastructure space because of AI, give us a sense of what is happening in the larger industry. Is hardware, AI infrastructure, the infrastructure for computing itself changing dramatically because of AI?
Yeah, absolutely. First of all, thank you for having me. AI has fundamentally impacted several areas of, I think, our lives and collectively industry, whether it's productivity or improving medical sciences and so on. So where we are right now is in some ways the early innings of AI, and to deploy AI, the infrastructure needs to be redone. Historically, when it comes to compute type of servers in data centers, they traditionally use a CPU-based architecture. You would have two processors with them. Now you have GPUs and accelerators that are specially built for running the AI workloads. So to that standpoint, it's a complete change or upgrade of infrastructure that needs to be done in data centers and hyperscalers. So that's the transition that we're seeing. There are several reports out there, but some of the things statistically to quote a few numbers for you, I think at this point about 2/3 of the companies servicing various kind of products are already using AI or considering using AI. The expectation is this will grow to about 80-85% in the next year or two. So the demand is there, the value is there specifically for generative AI or Gen AI, like the way it's called. If you think about the infrastructure itself and look at the various announcements made by the hyperscalers like Amazon, Microsoft, Google, Meta, and so on, I think the estimate is just for next year, there would be about $300 billion of capital investment to upgrade the infrastructure. Okay. That's about 25% higher than this year, and it's double of what it was in 2023. So clearly there is this, in some ways people call it the arms race going on in order to make sure that these large companies can essentially deploy AI at scale with the infrastructure that's completely overhauled to support the kind of computational capabilities required for training, inference, and other use cases that are tied to AI.
Okay, so you're saying the hyperscalers, data centers and all are what, already significantly AI led? I mean, what, how much of it is AI compute and all that now, you think?
Yeah, so the transition has been going on, to be honest with you, for the last 3-4 years. But I think, like they always talk about, the aha moment was when ChatGPT sort of came out and everyone understood for the first time as end consumers what AI could do to them. So obviously that acted as a catalyst for deployment of the AI infrastructure. And like I noted, the investment has gone double literally from last year, 2023, when ChatGPT came out, to 2025, where we expect it to be over $300 billion, just the hyperscalers alone. We're not talking about the enterprise AI or edge deployment, which are additional waves that are expected to happen in the whole rollout of the AI for all kinds of use cases.
Okay, okay. JC, same thing to you. I mean, dramatic change. You've been in the industry for so long. Have you seen this kind of inflection point in some sense? What kind of changes do you think is AI bringing?
Yeah, thanks, Sujit. I think thanks for making me part of this forum. Very excited to be here. If you really look at, overall, and whichever report you believe in, but we are, semiconductor is a $600 billion industry overall, and projected to be $1 trillion by 2030, 2032, depending upon the growth that we will see. But whether it happens in next 5 years to 7 years, I think it's going to go through a tremendous growth cycle in the coming years. Now, within that, I think AI would play a very, very important role in having this growth either get accelerated or be a big proponent of this growth going forward. And, one, I think Sanjay, very well talked about, how the back end, the data center is, going to provide this growth. But there is also the other side of the story, which is the edge story, how our edge devices, whether it is our mobile phone or our cameras or automobile, the chips that go into the automobiles, how they are going to be, more intelligent and provide more efficiency versus throwing everything onto the data center side of it. And then second, I think on the data center side, from AI perspective, my company, GlobalFoundries, I think we are also looking at how we make the whole GPU, the server side, more efficient, more energy efficient, and provide the technologies like silicon photonics to be able to provide the scale that Sanjay and team talked about that is required in the AI space, right? Now, to your second question of do we see that inflection point? Have I seen it? A couple of times. I think the Y2K was one place. In my life cycle, at least what I remember was a great cycle for semiconductor growth, electronics growth that happened. The second was the internet. The use of internet making every company more efficient. It was not only the semiconductor industry, but every company becoming more efficient and becoming more powerful using the power of internet was the another inflection point. I see, the AI is even more prominent and going to be more prominent for, of course, the semiconductor industry, which will power the growth of AI in some senses, but also every industry, that will be able to take the advantage of, the AI boom that is coming.
So those earlier inflection points as well, you saw semiconductor companies becoming very important at that point, is it, to make it more efficient or whatever?
Yeah, make it more efficient, make it more faster sometimes, make it more efficient from, how we do our work, how we live our lives, how we get entertained, and, so on and so forth. And, with AI, I think every industry is going to become similarly more intelligent, more efficient, and bring more power to, how we work, how we lead our lives, and how we take medical advices, or, how we travel, for example.
Okay, okay.
If I can add to what Jitendra said, he gave a great example of the internet being one of those transformative technologies that happened in our lifetime. What I would want to draw parallels to with AI Remember those days when there used to be those dial-up connections and you're trying to connect to the internet? That's the stage we are right now with AI, meaning there is lots more innovation and growth that's expected to happen. So truly speaking, this is not only a new era, we're also in an early stage of that era, which is equivalent to the dial-up era that we had in the internet, or the dial-up technology that we had during the internet era.
Okay, so the best things are yet to come. Shivu, tell me, I know Astera Labs is in the whole connectivity infrastructure space, and the whole idea is to speed up, become more efficient, make this whole AI infrastructure a lot more efficient. Give us a sense of what exactly Astera Labs is doing, the kind of connectivity infrastructure that is required in today's AI age.
Sure. First of all, thanks, JC, for being accepting to be a part of this panel.
Pleasure.
I think with the kind of verticals we are talking about, Sanjay talked about verticals, JC also talked about multiple verticals where AI is being implemented. I think that you can imagine the workloads the AI infrastructure is going to handle and trillions of parameters it needs to process. Now with this, the way you construct the data centers or the AI infrastructure itself has changed. So what used to be, I can give you 2 data points in terms of how the infrastructure has changed. If you really look at the way it was earlier, the motherboards were, they were like a 2 CPU kind of a simple motherboard. Today, when you look at a motherboard, you're talking about multiple GPUs or GPU clusters. You have CPU, you have NIC cards, you have accelerators. So it's become very heterogeneous in nature. So when you have a motherboard like that, you need a very strong connectivity solutions which leverages all the different protocols which are required for the connectivity, whether it's PCI, whether it's Ethernet, whether it's CXL. So you need something which understands these protocols very well. That's one. Second one is, most of the earlier times, the CPU used to talk to the IO device. Today, not only IO devices, they need to talk to each other. They need to talk to the GPUs, they need to talk to multiple different things which you're putting on the motherboard, which pretty much makes the interconnect solutions to be very reliable, very efficient, very low power, and ensure that there is high throughput and low latency. So that gives you a completely different challenge in terms of coming out with a very, very innovative connectivity solution, and that's exactly where Astera is right now.
Okay. Sanjay, you want to add to that? I mean, for AI training and inference, what does this kind of AI, connectivity infrastructure mean?
Yeah, no, I think Shiva did a great job of giving the high level. If I were to double click on that, so let's see, if you think from a workload standpoint, there is a training workload where you're training the models, which have now become trillion plus parameters. They're becoming more complex, various LLMs that are out there. And then you have inference. So inference is essentially trying to derive an answer to a question that is generated through the parameterized models that are running. So you have those 2 workloads, and the way it gets deployed is through a GPU cluster. So imagine GPUs that are interconnected to each other and running the workload that's needed to train the different models with the data that's available, right? So generically speaking, you have this notion called scale up, where you have GPUs that are interconnected to each other. It could be an example where you have 8 GPUs connected to each other, and these GPUs are connected in a mesh network. Now, some technical jargon here, obviously, but mesh network simply means that every GPU connects to every other GPU, so that they all look like one giant GPU. Okay, so that's very different than general compute. If you go back to traditional CPU architecture, these were connected in a hierarchical topology. You have server, a server got connected to more server through a switch, and then you created a network in a tree structure. Here you have a mesh structure, which essentially means that more the number of GPUs, more high-speed links you have, more potential for things to go wrong. And that's where Astera sort of differentiates by developing technology that's fast and robust. Now, the GPUs also need to, at some point, you have only so much physical space, power, and cooling available to put them in one box, right? You need to now start connecting multiple clusters together to create a giant cluster. That is done through a combination of the scale-up topology combined with what is called a scale out, which uses protocols like Ethernet or InfiniBand to create these giant clusters with 100,000, 500,000 GPUs that are all running together in order to train the model and deal with a data set that is increasingly growing as more and more people are using AI-based tools for doing a variety of different use cases.
Okay, and you provide that connectivity between all of this, is it?
Exactly. So I described the problem, but if I were to state what's going on internally is that these GPUs are complex machines. They do a lot of different things, and companies like NVIDIA, AMD, and others have done a fantastic job of packing a lot of compute nodes inside these processors. But the fact of the matter is today, only about 51-52% based on various reports is when the GPU is utilized, meaning about 48% of the time, the GPUs are simply sitting idle, waiting for data or memory because the connectivity infrastructure is not fast enough or efficient enough, right? So what Astera is doing is developing technology ground up, which addresses the data, networking, and memory bottlenecks that are limiting the efficiency of these systems and the underutilization problem that we see in the industry today. So our technology is done to address these three things.
Okay, and these are applicable to all AI use cases?
Absolutely. So for us, today, most of the commercial opportunities are in the training and now transitioning to inference. But as JC said, as you start thinking about edge, the technology that we're building will start getting deployed in various different forms. Today, we service Ethernet, CXL, PCI Express, and the newly formed standard called UA-Link, which Astera is a founding member and part of the board for GPU to GPU interconnects. So we service these 4 protocols to enable or resolve the bottlenecks that you see with data, networking, and memory. And we develop products that allow our customers to have higher bandwidth between the GPU to GPU connection through our retimer devices. We provide them CXL memory controllers where the system integrators can add more memory for the GPUs or CPUs. We provide fabric devices, switching devices that are used to interconnect the GPUs or interconnect the GPU to the CPU subsystem. So we are essentially providing multiple devices that addresses the connectivity or the nervous system that's needed to implement an AI server. And we do this both over copper media as well as optical.
Okay, fascinating. JC, tell me, I mean, you mentioned edge. Sanjay was also just mentioning edge. I mean, there are also similar kinds of changes happening, is it? The kind of chips you need, the kind of infrastructure you need?
Yeah, very similar. I think this has been, growing over the last, many years. Even if you, take the AI world today, it is much, much more required. The intelligence on the edge, the compute on the edge that, people can do, whether it is your smartphone or your automobile, or, the chip in your refrigerator, so that lot of that intelligence and compute, if that can happen on the edge, that, creates a great advantage as far as usage model is concerned, as far as experience of the consumer is concerned. But besides that, I think it provides a lot of advantage to really the usage of power. When I say power, the electricity, right, and bringing the efficiency up, reducing the power consumptions most on the data center side of it, right? And then adding to it, the solutions what GlobalFoundries has is on the power management of it, so that the power switch can happen based on the compute you required versus you always are using the high power intensity when the compute is not as intensive or not required, right? So those are one. And then on the, if you go on the data center side of it, I think Sanjay, put it very nicely and very simply, the problem his company is trying to solve on the interconnect, so that the GPUs and the servers are not waiting for the data to come in. The data can be given faster. And that is the same problem the GlobalFoundries is trying to solve for our customers, on how do we provide that faster transfer and not have very expensive resource waiting. And that is what I mentioned, right? How do we move from new technologies like silicon photonics, from electrons to photons, because the transfer can happen faster. So that is the two both sides of the play for a company like GlobalFoundries is trying to do and solve problems for our customers.
Okay, and even as you're trying to do all this, are there any challenges that the industry is facing?
Well, of course, the always when you are trying to address the next generation of technologies, there would be challenges. But I think we see more this as an opportunity. What we need to give to the growing demand in the ecosystem versus it's a challenge, because making sure that we bring out the new technologies from compound semiconductors in the GaN space, so the power management can happen better. Bring in the technologies that I talked about, silicon photonics, so that that interconnect data transfer can happen faster. So it's more of an opportunity, and something that the semiconductor or a foundry business, as a foundry company, we need to do that and be ahead of the innovation cycle there.
Okay. I want to ask Shivu a question on the local, you set up a Bangalore office and all that. Before that, I just want to ask you, you just had a great IPO. I was just looking at your share price and it's like, boom. I mean, it went down a little bit and then it's now like zooming. What does it signify for the semiconductor industry, you think?
Yeah, I think it's a great moment, right? I think semiconductors, I want to say, in many ways was underappreciated for many reasons. I think with the supply chain crunch that happened 2-3 years ago, I think for the first time the world realized how foundational a technology like semiconductor is in our daily lives, right? So that's where I think the realization has started. Now for us, at least for Astera, we have two key things going on. Of course, we are developing semiconductors that are foundational. We're also foundational to the deployment of AI infrastructure worldwide. Astera is fortunate to be in the heart of all the major AI infrastructure that's being built out by hyperscalers all around the world. So we are in that position where we are in the front row seat. We have several hundreds of design wins that are ramping right now. We are in that place where customers trust us. They see us as a innovation partner. They see us as their extended engineering team, and they're coming to us and saying, hey, you guys have figured out what is needed for AI, have the right device architecture and just overall technology that's needed. And now it's about, can you do this for us, that for us? I think that's a great position to be in, which is probably what investors are starting to realize, is that Astera's pure play AI and the technology, the innovation, the relationship, and how we are conducting business is something that has set us up to be a great iconic company in the industry. And I can only speculate, but those are reasons, and our revenue is obviously speaking for itself. We grew our business between last quarter to this quarter, Q3, about 47%. Year on year, we are like 200-300% if you look at various quarters. So we are in that stage where we are growing with third-party GPU-based platforms like NVIDIA, AMD, and others. We are at the heart of all the hyperscalers that are developing their own internal accelerators. We are developing products like Scorpio, which is our fabric devices, meaning we're getting deeper and deeper into the infrastructure that's needed for AI. So overall, it's a recognition of our technology and our ability to execute and be a great partner to our customers, and that's reflected in our business, and the stock market has been recognizing that and rewarding us.
And you become very rich, all of you. I'm sure, great IPO. Congratulations on that one. Shivu and JC, I want to ask you, both of you have been in the Bangalore ecosystem for many years, and Shivu, you set up Astera, with Sanjay, major center in Bangalore. Give us a sense of the Bangalore innovation ecosystem and why you thought Astera should be based out of Bangalore.
Sure. I think, as Sanjay said, the founding team and the first set of people made sure that we got the front seat. I think what we need to do is block the next 20 rows behind so that, the gap between us and whoever is following us or competing with us, we keep increasing the gap. The only way you can do it is with innovation and ensuring you're coming out with more cutting-edge technologies in the interconnect space, right? So to do that, definitely Bangalore is one of the places which can enable this. I've seen the Bangalore transform from being a pure IT services, as we were talking about Y2K kind of segment, to where we are right now. It's a deep tech capital of the world right now. There are more than 500,000 plus AI, ML deep technologists in the region. We have more than 500 native AI, ML companies in Bangalore right now. So if you really want to come out with a solution in the AI connectivity space, you need three things, right? You need to have deep technology knowledge and skills in the AI, ML domain. You need to have semiconductor experience. And Bangalore has more than 60% or 70% of the chips across the world is being designed in Bangalore.
60-70% of the chips in the
world is getting designed here. The numbers are much higher in the recent conversation I heard. But you have the semiconductor experience here, you have the AI, ML experience here, and the startup ecosystem actually has that energy and the innovation mindset. If you really want to have a cutting-edge solution, you need all three of them. Remember, in the last 10 years, all innovations are at the intersection of two different technologies. And here we have three right now going on in Bangalore. So if any innovation has to happen in this domain, I think Bangalore is the right place. And we have the talent, we have the ecosystem, we have the entire startup, and of course the universities, right? Whether it's ISC, whether it's IIIT, whether it's some of the private colleges. I think we have the right talent. We are not just adding numbers to the talent. Of course, there are more engineering colleges coming up. We are also adding depth in the last 20 years. So I think it's the right time. If somebody is exploring solutions in this space, I think Bangalore is the right place. And that's the reason why we started with Bangalore.
How are the academic institutions in Bangalore for semiconductor-related research? And
most of the educational institutes today, earlier it used to be pure play electronics and computer science. But if you really look at any of the syllabus right now, whether it's VTU, whether it's undergraduate programs, there are actually specialized programs coming up in VLSI itself, which never used to happen earlier. So MHRD actually and UGC have approved a specialized course in VLSI engineering. And most of the private schools are actually adopting it. We already have the first batch going on in multiple colleges. And I think they'll be the right people with the right background who will be entering this market in a big way in the next few years.
Fascinating. Yeah. JC, same question to you. You've been there in Bangalore for many years. You've been with Intel for many years. Intel was one of the first to actually establish a campus of its own in Bangalore. I think they owned the campus, if I'm not mistaken. I remember many years ago writing a story on something that you called a Whitefield chip or something, which probably did not take off, but then lots of chips out of, I'm sure, was built by the Intel campus in Bangalore. Give us a sense of the talent here and semiconductor talent in particular.
My answer would be the same that you already said, right? But yes, first of all, I think the talent that is available here in Bangalore and Karnataka. But by the way, for GlobalFoundries, we have two design centers now. We have majority of our workforce is in Bangalore, but we also have Kolkata, which we call it our Kolkata Power Center, which came through an acquisition of a company we did in the GaN devices space. Right? So we have now two centers. But I would say if India, I just look at it, I think from talent perspective, it is great place where you get the talent in the technology space available here. Bangalore in specific, to your question, is the talent availability and the academic institutions around us, yes. But there is a lot of people who want to come to Bangalore. so from every part of the country. And now I also look at, some of the other parts of the world people want to come because of, what Shivu talked about, the ecosystem that we have over here. Now, when I talk specifically for foundry company like GlobalFoundries, we also see here our customer base has great design centers which we can interact to over here. Those are our global customers, but we are also seeing a lot of fabless ecosystem developing in the country, we want to make sure that we can help this local fabless ecosystem succeed, grow the local fabless ecosystem, and make sure they have access to the technology know-how and the capabilities that we have, so that they can bring their products faster to the market using the foundry process technologies that GlobalFoundries has, right? So I would say talent, the growing fabless ecosystem over here, and the last one, it is very, very important that the support that we get around from the government entities, government organizations, both from the federal side of it or the central side of it, and also from the state government. We have centers in both in Karnataka and in West Bengal. So the kind of support that we get and the accessibility we get, so that our needs are met faster. I think those three things in combination makes India and Karnataka and other states very, very attractive place to
So the
build.
Kolkata talent is interesting. You have local people there in that center.
Yeah, we have it's a small center right now, but we intend to grow that Kolkata power center over there, and make sure that we may be the first one in the GAN side or the power side of it, but make sure it becomes a great ecosystem on the compound semiconductor space.
How's India on the hardware side? Is there
All in the
good
hardware
talent in all our hardware?
those
Generally
are-
hardware talent?
Those are hardware design, very core technology, developers over there.
Okay.
Can I add one other point to the three that JC said, which for me is the most foundational, which is the mindset change that we're seeing. I was visiting universities during this trip. I was talking to a lot of VCs and startup folks. It's very clear that everyone now wants to, not just solve a problem that they've been given, but also identify the problem and do so in a way that's very differently done compared to anyone else. So for me, that the mindset shift that's happened is a very refreshing thing, because for us, of course, I moved to the US several years ago, and I always enjoyed that product mentality, that let's solve the big problem, let's make a successful business type of mentality. That is starting to happen, at the generation that's coming up right now. So for Astera in particular, what we're doing is that this perhaps would be the first, let's say, design center, R&D center, innovation center, whatever you want to call it, where not only are we going to develop some of our cutting-edge products that will cater to the worldwide hyperscalers and AI infrastructure, but also we're going to be setting up some incubator centers. We'll be hosting a lot of startups and entrepreneurs that want to essentially take their ideas, but they need a platform, because hardware and semiconductor is not for the faint of heart when it comes to the infrastructure cost. So what we intend to do as part of Astera is that not only develop cool products that are bleeding edge, but also make sure that we provide a platform for the innovators, for the entrepreneurs out there that have been itching to essentially bring their ideas out and have a platform and a blueprint to essentially take those products to market and essentially create a vibrant ecosystem that not only is executing, but it's also on the forefront of identifying ideas, taking that to market, and creating successful ventures.
Yeah. This is big. What you said a little earlier, I'm beginning to hear more and more from people that the Indian talent is not just taking orders, but actually thinking innovatively to see how they can solve problems. Sitting in the US, how do they today view India? The kind of work that we are doing in the semiconductor space particularly?
Yeah, no, absolutely. Just to put some statistics, right? I think there are reports out that talk about like 20% of the global semiconductor workforce is Indian or people of Indian origin. So there is tremendous amount of know-how. So what has continued to happen, like if you go back to the US as well, when we moved to US, we were in that mode of give me the work to do and so on. But today, if you look at all the major companies, you see people of Indian origin either at the helm of it, CEOs and C-level, or the very senior positions. So we are at a point right now as a community where the basic skill set of or values of working hard, working smart, being ambitious is starting to pay out in a big way in the US. But the next generation that is coming up in India right now are growing with that mentality, because they now have role models that they can look up and say, okay, if Sundar can be the CEO of Google or others that you can name in that category, that they're aspirational. They're saying, this is the role model I can follow. And that, I think, is a very critical thing when you think about how the industry is going to evolve and how India and the Indian community is going to evolve over time. And for us, this is the right time. To be honest with you, we are about, 6 years into our operation. A lot of people would stop by and say, hey, start an India center because it's going to be lower cost. And we were like, that's not the right motivation for us. We want to tap into the talent, but we want to also make sure we are ready for catering with the right product, right leadership, right model, which we now see that the time is right, because the government is supporting, the universities are supporting, the talent is wanting to get to that kind of mindset. So that's why we moved to India now and plan to grow the India site significantly, both for R&D for our current products, as well as the startup ecosystem that we want to enable, with Astera being a platform for them.
Okay. Shiva, you want to elaborate on the kind of work that Sanjay is saying you're going to do absolutely cutting edge work out of India?
So when he was talking, I was just looking for some data points. I just got it on the net. Let me tell you how it affects us, right? Look at, we already have heard about UPA transactions in India, right? Look at the Swiggy data. Swiggy delivers 2.5 million orders per day, right? They were at around $1.5 million just a year back. And this is just Swiggy. I'm not even adding Zomato to this.
1.5 million orders.
Orders per day, right? 23, Swiggy saw 124% increase in the orders. In Valentine's Day alone, India ordered 271 cakes per minute, right? All data shows the kind of volume the back-end infrastructure is handling. Now, if you look at the US, for example, you're ready to pay $10 for a service. So you can put 10% of it, $1 for the infrastructure. In India, you're spending $1 for the service. So what you're going to put on infrastructure is only 10 cents. Now, the world data centers, the world infrastructure might not actually suit for India in the coming years. So you will see a lot of innovation in this whole data center itself in India. So not just made in India, made for India will come in. And that's when companies like Astera will be able to not only leverage this, but also be a part of the journey of how do we really change and morph the infrastructure itself for a country like India. Because I think the solution, what exists today, as he told, we're just at the beginning of the innovation cycle. A lot will happen. Again, this is just one company. You can imagine the kind of companies which is coming up here. Each of them require a strong data center in the back end, a very strong compute at the back end. And when you have these kind of data centers compute, you really need connectivity. You need someone to look at it and say, 10 years ahead of the curve, you need to look at what kind of payloads we are talking about and what kind of infrastructure which will come up, and do we have a solution for it. And I think that's a reason why I said you need to have different perspectives, different use cases to understand and to even come out with a solution. As Sanjay said, I think India has always been good at solving problems. Right? Somebody comes out with a problem, we're very good at solving problems. I think we are at a stage where we can start defining the problems and identifying the problems and defining it and, of course, work on it. I think we are at that cusp of that transition, and hopefully we'll see that. So whoever is joining Astera Labs, the first set of people, the only question I'm asking them is, do you like to solve problems? Do you like to define problems? If yes, be a part of us. I'm not trying to set up another ODC, which is Offshore Design Center. We're trying to set up a center which will take concept to parts, which means you need to understand not just one domain, which of course you need to be very, very strong in one particular domain, but you need to have a full view of the entire cycle. Otherwise, it will be very difficult for us to work together and make it happen. So it's a big challenge. Sanjay has
what
thrown
are
it
the
on us.
potential pathways to reducing infrastructure costs so much?
We are at the beginning of that curve. We'll have to see. There are companies, there are startups which is already working in these areas, and we are partnering with them. So you will see many different solutions, and it might not be
power efficiency.
Of course,
much better.
power is definitely one of them. That's a universal problem right now, irrespective of the kind of this one we have. We might see many different ways of doing it itself. So I think.
Sujit, I will just add to few points that came to my mind just now as I was listening to Sanjay and Shivendra. If you look at India ecosystem and how the tech companies or any other company who wants to look at India, either from the talent or otherwise, is we need to look India not just using the talent for cost perspective. Sanjay mentioned that, and I totally agree to it. I think the transformation that is happening is what I just said before was, hey, if the semiconductor industry is going to grow twofold in the next 7 to 8 years, there is a lot of talent requirement that is going to come in for this industry. That would be a global requirement. And I think the India expertise that we have, whether we have 20-25% of the designers already in India, or how many SOCs the people are developing, I think all of that talent, can be well used globally, not just for India. It's I think we are going to be a talent pipeline for the global semiconductor and tech industry. Yeah. I think number one. The second one is companies also need to look at India as a demand story. Today, if you look at the consumption of semiconductors in India, I think it's close to between $35 to $40 billion. Let's say $40 billion. And all the assumptions are that by 2030, this will grow. Semiconductor demand in India is going to grow to $100 billion, which will be 10% of the overall global demand. And that demand, how do you cater to that demand? Some of the usage models are going to be very, very specific to this ecosystem. The infrastructure requirements, the cost requirements, the efficiency requirements are going to be a little different for this infrastructure. And you need to look at, if this is going to be a 10% of the global semiconductor industry or consumption, then how do you cater and leverage that and be the first player to leverage it? Yep. And that can happen with using the ecosystem. You can't do it alone, and that's why the startups, the fabless ecosystem, how do you make them successful and ride it with them?
Yep. Can I add a couple more points? Because I think it's an important topic. First thing, you asked the question of how do you bring the cost down to the Indian, the example that Shivu was giving, the 10% thing, right? That happens through startups. Yeah. I'm a firm believer that for this kind of dramatic improvement, you need a team of people that are not only innovative, but they're willing to break some rules to get there, right? And that happens through smaller companies, startup ecosystem. That's how Astera became what it became, is to do something dramatically different than what large companies are willing to do, that are driven by certain KPIs and models to deliver, right? That's one point I wanted to make. The second point I wanted to make is this India and Indians as a talent pipeline versus India as an opportunity, right? We are coming here not just for talent. We are coming here because India is an opportunity. And there are some models that statistics-wise, if you want to look at, today India is what, 1.3 billion, something like that. So the model is, if you look at the demography and population curves, the $1.3 billion over the next 25, 30 years is modeled to go up to about 1.95 billion, right? Before it starts tapering down and coming back to what it is roughly around what it is today. Right? Meaning over the next 25, 30 years, there's going to be a boom of consumers that are already tech savvy. And there's data savvy in India because everywhere there's data. And AI would be a key enabler to support the different goals, whether it's productivity or retail or what have you. So that is going to drive, along with the startup community, to achieve that India as an opportunity that we're talking about. The third one I would say is if you look at worldwide, I mean, today India has already surpassed China from a population standpoint. And if you look at the population profile of China, which is about 1.1, 1.2 billion, over the same period, it's actually shrinking to about 700 million. So you start looking at the world dynamics here, right? Population-wise, consumers-wise, technology-wise, things are coming together in a way that I think over the next 25, 50 years, India as an opportunity, India as a talent house, India as something that will have a significant presence in world economy and companies coming here to do business is going to dramatically evolve. And that's why I think the timing is right for several reasons, including the government's putting more attention on semiconductors, manufacturing of semiconductors, because now it's also a geopolitical thing, given how most of the manufacturing for wafers and things like that happens in countries like Taiwan that have various geopolitical considerations that start coming into play.
So I think one more thing I want to also look at it is, if you really want to look at innovation in chip design itself, we might have to look at how we design chips also will change over a period of time. And that can again happen with the kind of talent we have here, especially on the AI/ML side. So if you really talk about AI/ML in chip design, majority of the techniques are pretty much in the optimization level, which is at the very basic level, right? So then you move towards analytics. So you try to get more information about how you do things and tweak it to make it better, make it right in the first time when you design chips. Then you get into assistance mode, right? You're designing chips, you want to understand how the other team is doing, how the other blocks are doing. So you try to do an assistance and finally do a creation part of it. But if you look at the AI world today, they are very progressed on the creation part of it, whether it's creative world or any of those things, right? ChatGPT is an example. But semiconductor still, again, is mainly in the optimization analytics side. If you really want to look at how do you change doing this, you need to put native AI/ML guys in semiconductor design cycle, which is very unique because usually when we start hiring, we want somebody who's very good in digital logic, analog circuits, or protocol kind of guys. But now just imagine somebody who's got a fantastic domain knowledge and you have this AI/ML guy sitting with them, he or she might actually change the way you do things. And I think that's going to transform in a big way in the coming years.
So is that what you're doing in your center?
Yes, we are hiring. So whenever we look at the team, we are trying to make sure that everybody comes in with a very diverse skill set, which can improve the way we do things. Very, very important, right? You need to have technology domain expertise, no doubt about it. But you need to come in with that unique skill, which will completely change the way you do things.
Yep.
Because that's the only way fundamentally you can change the innovation cycle.
Okay.
Right?
JC, is that something similar you're doing in GlobalFoundries in your center here? You have quite a substantial presence in India, you said.
Yeah, very much. So Sujit, so in India we do three major activities as far as our foundry business is concerned. We do process technology engineering here. We have 10% of our workforce is PhD. I think not many centers can boast of that. Larger centers, I would say, can boast of that. So we do process technology. We do IP design, reference designs for our customers from here, and also we do what we call it virtual fab or fab operations, out of here. In addition to some of the enabling functions that we do from IT to HR services and so on. Now, one of the things I think from AI perspective, what Shivu also alluded to, would change the dynamics of how the semiconductor overall ecosystem works is if a lot of these designs become AI enabled and they become easier for many companies to do the customized designs for their particular needs rather than taking off the shelf common solutions SOCs. If the AI supported designs become easier to do, cheaper to do, efficient to do, I think that will change how even the relationship between the fabrication of the fabs and the design community, right? And the more customization, the more people are able to do it, it will be kind of a revolution on how different solutions according to the usage models can go at the hardware level, not only at the software level, right? So that is what we are very excited as a foundry company, and at GlobalFoundries we think that will be a game changer for us going forward in the coming decade.
Okay, very interesting. Are you looking at working with startups in India and all that?
Good question, very timely. We work with the local ecosystem. We work at the academia level. We are engaged with at least 20, colleges, top 4 or 5 marquee where we do research work and so on. But just on, coming Friday, we are announcing a program called GF India Technica. This is for to support the fabless community in India so that they get access to our technology, what we call it PDKs, access to our manufacturing so that they can do the test chips, we call it MPWs there. And also, more importantly, as I said, we have a very high talent workforce here. 10% of our workforce is PhD, 85% are doing high-tech work in India. And we want to make sure that talent is available for startups, so that startups can take help of those talents and design and innovate using the know-how these technologists and PhDs have in India. So we are going to be opening up our technologies for these startup ecosystem or fabless folks in India, local fabless companies, get them engaged with our technologists so that they can develop faster. And then lastly, we are creating platforms where every year, just this Friday we are going to be doing it, all the roadmaps that we have on our product lines, we are bringing our leaders here, technologists here, to make sure they can give them the roadmap of next 3 years. And we are going to do that every year. So create the platforms where the startup community can take advantage of, rather than trying to reach some leader, in their individual capacity.
Wonderful. Sanjay, tell me, 2017 is when you started. Just before that, you were National Semiconductor, is it? What were you thinking when you decided to start Astera? You anticipated, of course, Gen AI and all came much later, and the sudden demand and all that. But when you started this?
Yeah, so we were in TI, which National
TI.
was acquired by TI in 2012. So we were part of TI, and Jitendra and I, my co-founder, and Casey, all 3 of us were there. So we've always been in situations where we created businesses back in both in National and TI. So I think in 2017, I remember, we saw this sort of transformation happening called heterogeneous compute, right, where you had GPUs, accelerators, CPUs. It was very clear that the connectivity technology that was developed for the last 20, 25 years were more CPU-centric, not to the point of what is needed now. So to that standpoint, our thesis was that one, connectivity has to be redefined for the accelerated compute type of architecture with GPUs, CPUs, and so on. But the other big trend that we also saw was that the hyperscalers, the word is used for Amazon, Microsoft, and all these companies that have large data centers, they were starting to get more vertically integrated, doing their own chips. So we saw an opportunity for a new style of company that is essentially developing the cutting edge technology ground up for this new architecture. We also saw a business model where if the hyperscalers are doing their own chips, then they don't need a component vendor alone. They need someone that can partner with them in terms of matching up to the product or the GPU or accelerator they're building and provide the infrastructure around it to be able to interconnect that GPU to other parts of the subsystem. So that we saw as an opportunity that needed to be addressed very differently than what traditional companies have done, including TI. So, of course, TI has been great for us. We learned a lot, and we addressed that with the management. TI also, in that mode, has a business model that is more centric around automotive and industrial type of use cases. So it was one of those situations where it didn't fit the business model. And we were standing there thinking whether we, continue to give up on the idea or do something of our own. Thankfully, we decided to take the plunge and we never looked back. So Astera was born on October 26, 2017. Just like any other Silicon Valley startup, it started in my garage. It still gives me the chills when I think about it. So 3 of us sitting in a cold garage, figuring out what we need to do. with the biggest worry being, hey, are we going to raise funds? Because in semiconductor, there's no such thing as a seed round. Your first round is a large round because, you know, we need to pay for folks like GM that charge a lot of money for manufacturing and fabrication. So we decided to start with the highest level of funding. We decided we won't go to traditional VC because at that point, and now it's evolved, but generally VCs don't like to invest in semiconductors, just given the high investment level as well as the risk associated with that. So we decided to bring in folks that understood semiconductors. So we went with founding investor called Avigdor Villens. He had started a lot of the companies that are today are part of bigger companies. So we started with that premise, and then never looked back. Now here, a little over 6 years since we started operations. We are a public company. Of course, our revenue has been growing significantly, like I noted. But more importantly, what we are right now is we have become so integral to the AI infrastructure that there is so much more to do, so much more opportunities, which is what is very exciting. And starting the design center and the collaboration we're doing with the startups here is only going to accelerate.
Wonderful. Inspiring. Such an inspiring story. We are almost out of time. Quick one from all three of you. To all the youngsters listening to us, what should they learn, especially for getting to your space, or if they're thinking of becoming an entrepreneur, any messages to them? Shivu, you want to start?
Yeah, I think deep technical knowledge and command over one particular area is very, very important, right? Don't be a generalist. Be a specialist in one technology area. I think that's the most important thing if you want to sustain a career in a semiconductor domain, plus have one skill which is completely different than the semiconductors, right? It can be AI/ML, it can be statistics, it can be something totally different, because that's where the innovation will happen. And I'm seeing this with many kids because they like to do different things, and I really hope they invest their time and energy in these things. Gone are the days, 95 I passed out. We milked that 4 years of education for next 20 years. I don't think you can do that anymore. All engineers, your lifespan in semiconductor industry is not more than 3 years. So if you do not upskill yourself, if you do not go deep, I think you'll be in big trouble. So my only request, my only suggestion is to make sure you keep upskilling yourself, pick up the right challenge, and identify the right challenges and solve it. I think that's the only message I want to
specialization plus an additional skill.
Correct.
JC?
To the youngsters, I don't like to give advice, but I'll just tell them that, hey, I'm jealous of them, right? Because this is, I can't see any other industry in the next 2 decades will continue to grow at the pace that is unprecedented, right? So if you are youngsters and you have curiosity of doing something great for not only in the technology world, but if you want to do something great for the society itself, I think this is the industry, and the solutions that the semiconductor industry, electronics industry is going to bring is going to change how we live our lives. How do we do our businesses? How do we get entertained? So which industry can be more exciting than this? So I would say, if you are really into doing something great for the community in general, build your careers, create lot of wealth, next 2 decades, I think this is the place to be.
This is the place
I
to
wish
be.
I was starting the career now.
Sanjay?
Sure. I like to give advice, unlike JC, I don't feel that old. So I think, 3 things I always say for budding entrepreneurs out there. First and foremost, back yourself. We get one life. You want to make it count. There is no such thing as a bad step you can take, so go for it. I always say that if you don't back yourself, no one else will, whether it is entrepreneurship or any other things that you want to do. The second thing I say is that listen to the customers, because a lot of times you have people that start companies with a solution that they want to that they've thought about and not really done enough work to talk to customers and many of them to validate and understand what is the true problem. You're very quick to say, oh, it's a problem, I can solve it, let me go try to start building POCs. The second advice I would give is listen to customers. The third one I would say is that really the fundamental thing that separates anyone, or in fact the only differentiation I see today is execution. Okay, end of the day, everyone has ideas, everyone has money. These two are commodities. The true differentiation in today's world is execution. Can you deliver? Right? Astera was not the first company when it came to our first product. There were 4 other companies ahead of us. But we innovated, we executed like there is no tomorrow. And that is what created a $15 billion company. So if you want to succeed, then first back yourself. Second, listen to customers. Third, innovate and execute. And then let's see what happens. That's what I would say.
Wonderful. Great note to end on. Go for it. That's a message. Great industry to be in. Thanks a lot, Sanjay, JC, Shivu. Really nice having you on this platform. Hope to see you again sometime and wish you all the best.
Great. Thank you.
Thank you, Sujit.
Thank you.
Always great.